Well, this is specifically what makes a combinatorial proof. These are tricky proofs. I mean, they really what you're doing here is you are creating a scenario in which you're counting the same thing twice. And because you're counting the same thing twice, obviously they're equal, but you're doing it in different ways. And so
Yeah,
one way
yeah,
is the left side, the other way is the right side. And so
yeah,
what he meant by definitions is you're actually defining what are the things, right? What are you actually counting? And so we can start with the law of universal generalization, right? I've got a statement here about a bunch of variables, so let's create them. Let n, k1, and k2 be integers, and certainly there's going to be some restrictions on them in order for all these things to make sense. Um, k1 must be less than or equal. Oh, they're all positive integers or zero, I guess. And then k1 must be less than or equal to n, and k2 must be less than or equal to n minus k1, right? Certainly you can't choose more than you got. Okay, and so that sets up the variables. Now I just need to oh, actually on the right hand side I've got k1 is choosing from n minus k2. So k1 must be less than or equal to n minus k2 as well. And in fact, that comes from, yeah, this one. That's enough, right? If you move the k1 over, you get k1 plus k2 is less than n, and you get the same thing here. So in fact, I could just erase this, and that would take care of both. And so now I've got, okay, k1 and k2 together are less than or equal to n. Okay, so k1 and k2. So I need to come up with an idea of what am I working with here? What am I dealing with here? What do the things mean? So K1 is obviously going to be some chunk of the n things, and K2 is going to be another chunk of the n things. And so on the left, what are you doing? Out of the n things, you're choosing K1 of them. And then out of the n minus K1 things, okay, so out of everything that's left, I'm choosing K2 of them. On the other side, I'm first choosing the K2 things, and then out of everything left, choosing the K1 things. So there's lots of different ways you could visualize this. I mean, for instance, what if I took a group of n people, and I was assigning some of them are going to get a brand new car, and some of them are going to get a trip to Mexico. Hey everybody, let's take a break from the example for a sec. The example I'm doing here is really just a single example, and there are literally infinitely more problems you can run into on a discrete math exam. And odds are good you'll run into problems you've never seen before and be expected to apply what you know to solving them. But if you don't understand the content, you have no hope. So, if you're taking a university, if you're a student taking a university discrete math course, and you're serious about not just getting a good grade, of course, yes, getting a good grade, but if you're serious about understanding the content, then go ahead and click the first link in the description down below and book a free call with me. Now, back to the example. And so out of the K1 of them, I'm choosing which ones are going to get the car. And then
hmm
out of the ones who didn't get the car, I'm going to choose the ones who get the trip to Mexico. Of ways to do that is exactly the same as choose first off the number of people who are going to, or the people who are going to get the trip to Mexico, and then out of those who didn't get a trip to Mexico, choose K1 to maybe get a car. That's the scenario. That's what you're doing. That's what you're creating. So it's just a matter of writing that out. And yeah, the only way to write it out is to write it out with complete sentences and write it out as a an actual explanation. So I even typed this. Um, Consider a group of n people attending a game show where and K1 of them will receive a new car and um, here there. K1 of them will receive a new car, and K2 of them will receive a trip to Mexico, and no one can receive both prizes. Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough,
then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
Yeah.
And you think n is a big number, so n could be like 1,000 people, and you're
Yeah.
choosing 5 of them to get a new car and 5 of them to get a trip to Mexico.
Yeah.
What this does is, out of the 1,000 people, choose the 5 who are getting the car,
Yeah.
and then out of the 995 that are left, choose the 5 who are going to get the trip to Mexico.
Oh, okay. Yeah.
Or over here, choose the 5 that are going the trip to out of the 1,000, choose the 5 that are going to Mexico, and
Yeah.
then out of the 995 left, choose the 5 that are getting the car. Then to count the number of ways to do this, we can either first choose the K1 people who receive the new car, which can be done in n choose K1 ways. And then count the number of ways to do this. There are two options. One, first choose the K1 people who receive the new car, which can be done in many ways. And then of those not chosen, choose which K2 of them will receive the trip to Mexico, which can be done in n minus K1 choose K2 ways. Thus, the number of ways these prizes can be distributed is, and then now I'm copying down the formula on the left. And then two is just the opposite. So this is literally what you're writing on your paper. And so the way the logic works then, because they both counted the same thing, well, those two values must be equal then.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.